So now let's do the next part, which says method of identification of an alkane, alkene and alkyne. So there is this tabular column which is given in the end of this chapter, which is alkynes, where you will be having various tests to differentiate between an alkane, alkene and alkyne. This is supposed to be the most important part, because you will have a lot of application based questions where you will say give a chemical test to differentiate between an alkane, alkene and an alkyne, or they will give you a few names of alkanes and alkenes and you need to differentiate. So now generally the first test, which is the most common test, is passing the gas. Here the gas is an alkane, alkene and alkyne if it has very less number of carbon atoms. So passing this gas through bromine, so which is present in CCl4. So bromine is present in CCl4, and so it's an exceptional halogen which is dissolved in CCl4, and this gives it a color. This gives CCl4 a color which is supposed to be reddish orange in color. So this color is obtained on dissolving bromine in CCl4. When you pass an alkane, alkene and alkyne, you will have few observations. Alkanes are already highly saturated in nature, so it cannot undergo addition reaction, it can undergo only substitution reaction. So because of which there will be no change. That means the decolorization does not occur in the case of an alkane. While when you take alkene and alkyne, decolorization occurs. So decolorization occurs, and then the same thing, because decolorization occurs even in the case of alkynes, because it is supposed to be unsaturated in nature. So addition reaction takes place. So since addition reaction takes place, the decolorization occurs. So this is a very common test which you will be knowing. So next one says by using alkaline potassium permanganate. So potassium permanganate is nothing but KMnO4. It is supposed to be an oxidizing agent. So you make use of this as an oxidizing agent in cold and alkaline conditions in the case of alkenes and alkynes. So now in alkynes we wouldn't have learnt it under chemical properties, while alkenes we would have learnt it. So now you will be learning it newly right now. So alkanes, it does not have any effect, but the only effect can be conversion of the alkane to alcohol, as we have done long back in the first part, in the second part, which is alkane series. We would have done the series of compounds where compound A gets oxidized to compound B, compound B gets oxidized to compound C. So we would have done a series. So in that series, if we use KMnO4 or K2Cr2O7, you will be getting a certain compound. So that is the only way in which you will be observing a change. You will be observing a change in the products. So I'll just give a small recap. An alkane, so in case it gets converted to alkane, getting converted to alcohol is just a normal way. So normal way in which you will be using copper tubes, and then afterwards, in case when alkanes getting converted to an aldehyde is by using molybdenum oxide, and next comes your manganese compound. So an alkane, so getting converted to carboxylic acid or COOH. So here aldehyde is CHO. So an alkane getting converted to carboxylic acid is making use of a manganese compound at a temperature of 100 degrees Celsius is because of this potassium permanganate. So this is not a very distinct way in which you can identify that it is an alkane, because in the case of alkenes and alkynes, there is an even more distinct way in which you can identify it. The point is, when we have this acidified alkaline potassium permanganate, and when you add it to an alkene in the presence of water, like I will write a short reaction here, CH2 double bond CH2 plus H2O plus this nascent oxygen, which is in the presence of cold alkaline potassium permanganate. So you will be getting one compound which is known as CH2 single bond CH2 and then OH and OH here. So this is nothing but ethylene glycol or 1,2-ethanediol. We would have already discussed about this in the properties of ethene, but I would have mentioned one more thing. The color of potassium permanganate, which is supposed to be purple, will decolorize. So here purple color will decolorize. The purple color will decolorize. So here the same thing will happen, but then there is supposed to be a reaction, and then this reaction is supposed to be CH triple bond CH plus 4 units of nascent oxygen in the presence of KMnO4, which is alkaline and cold. So I'll repeat, CH triple bond CH in the presence of 4 units of nascent oxygen, and then in the presence of KMnO4, which is potassium permanganate, which must be cold, alkaline. So this on when you carry out this reaction, you will be getting a compound known as COOH, single bond COOH, and this COOH, single bond COOH, is known as oxalic acid. So this is known as oxalic acid. So here you will be getting ethylene glycol or ethane 1,2-diol, and then purple color will decolorize, and here purple color will decolorize, but then you will be getting oxalic acid, which is COOH, single bond COOH. While when I take the case of an alkane, when you have an alkane and when you have this manganese compound, which is known as KMnO4, you will be getting this carboxylic acid, but then there is no decolorization here. So the difference is not, the way in which you distinguish an alkane will be a little difficult compared to an alkene and alkyne. So next, let's do adding of ammoniacal cuprous chloride. So ammoniacal cuprous chloride, so when you add this compound ammoniacal cuprous chloride, where the reaction is not necessary to know, only the observation is important. So here there will be no observation. No observation in the case of alkenes. So in the case of alkenes, again no observation. Nothing will happen when you add ammoniacal cuprous chloride to an alkane. Nothing will happen when you add ammoniacal cuprous chloride to an alkene. But then for an alkyne, you will be getting copper acetylide. So you will be getting this compound known as copper acetylide, and this copper acetylide is supposed to be red in color. So since if you get copper acetylide or compound which is supposed to be red in color, that means it is supposed to be an alkyne. So finally, let's come to the last test, which says adding of ammoniacal silver nitrate. Again here is no observation. Here again is no observation, but here you will be getting a white color compound which is known as silver. It's supposed to be silver acetylide. So you will be getting silver acetylide. So in case when you add ammoniacal cuprous chloride, you will have no observation in the case of alkanes and alkenes, and in the case of alkynes you will be getting a red precipitate or red colored compound which is known as copper acetylide. While when you add ammoniacal silver nitrate, again no observation for alkanes, no observation for alkenes, while alkynes you will be getting a white color compound, and this white color compound is known as silver acetylide. So thank you so much. So please do like, share and subscribe to my channel. Hit the bell icon below. If you have any queries regarding this channel, please do leave comments below. Apart from that, so please do follow up the next video, which is nothing but a question answer session, which makes your learning complete. Thank you so much.